So, good morning. My name is Shraddha CS, USN 1BI 23 CS 196. So, the question given for me was to explain the implementation of a C program to find the subset of a given set S of n positive integers whose sum is equal to the given positive integer D. So, let's look at the algorithm. So, here we have the algorithm for sum of subset problems. S is the initialized value. K is the index of the subset value that will be calculated, that will be taken into consideration. R is the total sum of the entire subset. So we are setting x of k is equal to 1. So this x is the array which is basically like a visited array. It checks if the value is satisfactory for being included into the subset or not. So now there's a if condition, that is s plus s of k. So s is the initialized value. So this will keep changing based on the next iterations. Initially it will be 0. So s plus s of k. S of k is the value of the value present in the set at index k. If it is equal to 0, then the subset is found and the solution is printed. If it is not found, then what we do is we check if the next element when added up is still less than or equal to d. If it is less than or equal to d, then the function is recursive and the function is called to s plus s of k. So now your s value has been incremented by s of k value. So s plus s of k and k plus 1, that is the next index, and r minus s of k. Now the total sum will decrease because we've added s of k to the subset. So r minus s of k will be your sum value now. And then you basically check again, same iteration. Now there is another condition, say s minus s plus r minus s of k. So the initialized value plus the total sum is greater than or equal to the given d value, and s plus s of k plus 1 is less than or equal to d. This means that k does not satisfy as an eligible value to be printed in the subset, so k is eliminated. So when the value at k is eliminated, x of k will become 0. That is, the visited value will become 0 again, because it is not eligible to be put in the subset. And then it recurses back again proceeds with the next element. So that is the sum of subset function. Basically, this is the program. We have the header files and we have defined maximum array value as 10. Now s of max is the array in which the set will be inputted. X of max is the visited array, which keeps track of which which value to be entered to the subset. D is the maximum sum value. So this is the function of sum of subset. P is again the initialized value. K is the index at which the value will be considered. R is the total sum. Now again, like I discussed in the algorithm, x of k is made as 1 and it is checked if the sum is equal to d. Now when the sum is equal to d, then what it does is it runs a loop from I is equal to 1 through until it reaches index k, and wherever x of I has been marked 1, which means that it satisfies the conditions to be added to the subset, those numbers will be printed and your one subset is completed, so \n will be printed. So this is how the printing of the subset will take place in case it is equal to d. If it is not, then it is checked if the next value should be added and if it still is less than or equal to d. If that is the case, then p plus s of k is your new value that will be sent in the place of p, and k will be incremented by 1, so k plus 1 will be sent, and r minus s of k. So s of k will be subtracted from the total sum and function will be called again. So again, it will check whether it satisfies. If it satisfies, it will go through the for loop. If not, it will come here. Now, the other case that we talked about is that S of k does not satisfy to be added to the subset. In that case, we initialize x of k as 0, and we continue with the next iteration, the next recursion. So this is the main function where the main function call will take place. It is an integer based function, so you will have a return type, and sum here is initialized to 0, and the n value is taken. This is the total number of elements in the subset, and the set is added in increasing order. The reason why it is added in increasing order is because easier comparisons take place, and say the first element itself is greater than the given d value, then you can tell that since the remaining values are greater than the first value, subset cannot be formed. So that condition is discussed here. So it is added in increasing order, and then you have a for loop which scans takes in the input from the user, that is s of I, and then you ask the user to input the maximum subset value. So that is done here. So for I is equal to 1, I less than n, I plus plus, sum is calculated by running a for loop from 1 to n. So now this sum is calculated 1 in order to send the value to the function, and also because say the sum is less than the maximum subset value, then it shows that no matter what combinations of numbers you take, you cannot form a subset with that given set. So in order to check for that condition, sum is calculated. Once sum is calculated, you check if it is less than d or if the first element is greater than d. If either of these cases are true, then the subset is not possible, because if s of 1 is greater than d, that means the set value is too large when compared to the given input for subset value. And if the sum is too small, that means that the set is too small and no subset can be formed. So if both of these are false, then it will go to else part, which is the calling of the sum of subset function, that is 0, 1 and sum. And then you have your return 0, that is all. Let's take the output example. They've given value of n. So n value is 9. So set in increasing order is given from 1 to 9. So max subset value is 9. So now we know that 1 is not greater than 9. So s of 1 is greater than d is false. And sum of this subset is, sum of this given set is going to be 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9, which is going to be 45. So 45 is very obviously greater than the given subset value, that is 9. So this if condition is also false. So when both are false, it will go to the else part. It will call the function sum of subset with initialized value 0 and first index, that is index of 1, that is 1, and the total sum, that is 45. Now it will go here and it will check 1 satisfies, so x of k will become 1. 2 satisfied, so x of 2 will also become 1. 3, 4 and 5 do not satisfy, so the loop will, the recursion will continue. Again 6 will satisfy, so x of k will be 1. So when all of those are 1, it will check. So the p value when index is at k will be at 3. So 3 plus s of k, when index value is 6, the value is also going to be 6 for this input. So 3 plus 6 is 9. So it satisfies this if condition. So the for loop will run from 1 to 6. 1, 2 and 6 are the values whose x of I values is equal to 1. So only those numbers will be printed, and then print f of \n. So this is one subset, as you can see here. Similarly, other subsets, all the subsets are found until no more subsets can be reduced from the given input. So that was the sum of subset program. Thank you.